Hey guys, and welcome back. So we're gonna take a couple more notes today. Also, please remember to view the wave simulation on a different video here on YouTube, as well as complete your waves quiz based on that simulation and all the answers you've gotten from that. I've also posted notes for that wave simulation on my Google site, and you'll find the link to that either in an email that I've sent you or on the uh, PHS staff teacher website. So yesterday we left off with how waves affect each other if they're in phase or out of phase. In the top example here, they were in phase, so two waves were going together and they were actually building off of one another, so they would get larger. They would pretty much add to each other. The other one, when one wave was a peak, the other one was a valley. And then when this one became a valley, this one became a peak. So essentially, they were subtracting from each other and canceling out. All right, so what are we going to start with today? We're going to start with wave breaks. We're going to talk a little bit more about waves. And then tomorrow, we'll get into the different types of destructive waves. So a wave break is when the height to wavelength ratio, remember the height of the wave to the wavelength, peak to peak, exceeds a 1:7 ratio. So when your wavelength is 7 times your height, the wave gets too small and it becomes unstable. Okay, even out in the open ocean, whitecaps will form with wave breaks. Remember, when a tsunami hits, the wave height is only maybe 3 feet. It's not a large wave, but it builds up so much momentum as it comes forward towards the shores. So we're just gonna delete that for now. We don't need that in there. As a wave moves towards the shore, it reacts with the bottom. So we constantly have this moving motion. And finally, when that wave begins to hit the bottom of the shore, it disrupts itself. That's when it begins to curl over. As a wavelength moves towards the shore, it reacts with the bottom. The wavelength shortens and the height increases. Now the wavelength gets bunched up, right? Those waves start to get, so here's your wave, right? The waves start to get shorter and shorter together. And notice, as they get shorter and shorter together, here, it's a longer wavelength from peak to peak. But when they get shorter and shorter together, look at the height of that wave. It increases quite a bit. And as it increases, it begins to roll over itself. You'll see it right here. And that's when you get that tsunami wave, that crashing wave. So we have types of waves. There are plunging breakers, spilling breakers, and surging breakers. And you can see the different pictures here of a plunging breaker. It's one that kind of rolls over itself. Those are the ones that surfers, they want to hang 10, ride the pipeline. What's up, dude? That type of deal. And then you have your splitting breakers, or excuse me, your spilling breakers. Those are just kind of the rolls, small white cap on top. And then your surging breakers. Those are the ones that build up and they're just like a wall of water that come towards. There's no breaking of the waves. There's no white cap. It is just a wall of water. A plunging breaker. Yo, what's up, man? Hanging 10, dude, totally tubular. Those are the ones that people try and surf, all right? Because it has that break to it. It creates that tunnel. These waves break with a curve at the top. They're surfing waves. They are moderately steep beaches that decelerate the wave quickly. And you could see this steep beach that as the wave rolls over, it hits the bottom and it starts to fall over itself. It's a drastic change. The top of the wave flies ahead of the bottom. Okay, so the top travels faster than the bottom does, so it falls over itself. It's a plunging breaker. A spilling breaker, yep, people also surf, but we do not have, there's a small white cap at the top and you can see that here, but there's no breaking over itself, okay? So this is like where the previous one, the plunging breaker was like, whoa, what's up, man, hang 10. This one's like, whoa, what's up, man, hang 5. And the next one you'll be like, hang nothing because it's not a surfing wave. So these are spilling breakers. The wave just kind of fizzles out. It occurs on gently sloping beaches and it decreases slowly. So you can see here the wave has time, the bottom and the top kind of catch up in speed, so it doesn't necessarily fall over itself. And then your last one is a surging breaker. Not a lot of surfing on this one, okay? It occurs at very steep beaches where the wave essentially just rolls. There's no deceleration at first. It's like the wave hits a wall, kind of just stops. And it can be very destructive because all the wave energy hits in one full force, okay? It's just kind of like that wall of water that pushes forward. So that is it for today, guys. Nice and easy. Please make sure to remember to work on that waves quiz. And tomorrow we will be discussing destructive waves. All right, guys, stay safe, be careful. Make sure you're getting your work done, and I will see you all tomorrow. Mr. F.